Hello everybody, in this Rhino Grasshopper video demo, I would like to show how we can create this kind of sculptural form which seems to mimic organic biological elements. Okay, let's start. I've already created the initial surface for the creation of the design. Basically, this is created by using a revolve of a profile curve and having the deformable option set to yes, and by turning on control points and pulling them, I arrive at this form. Okay, now let's proceed with the rest of the task, which will be on Grasshopper. So I'm going to the geometry tab, put a geometry node, associate this to this. Let me hide this, okay? And I'm going to put points on this surface by using populate geometry. Okay, connect this here. Let's reduce the control points for faster calculation. Something like that. The next thing I need to do is to create a bounding box, scale it slightly bigger, and then apply a Voronoi 3D to it. Okay, so we're going to type bounding box, connect this. Scale this slightly bigger. I'm going to find the center using the volume node. Connect this, connect the centroid to the center. Let's scale it to a factor of, let's say, 1.2. Something like that. Okay, I'm going to hide this. Okay, now I'm going to apply a Voronoi to this. Okay, go to Mesh, Triangulation, Voronoi 3D, plug this here. Geometry is the box. Now I'm going to use the cells of the Voronoi 3D to intersect with the surface to get curves on the surface. Okay. To do that, we can use intersect, this one, which is the Grasshopper equivalent of object intersection. Okay, so I'm going to connect this here, geometry, connect this here. Okay, let me hide the rest. Okay, so you can see this is the result. Okay, and I think I need to do a bit of adjustments, but I'm not going to like really spend too much time on this. Basically, just want to connect this, and we can do some fine tuning on our own later on. Okay, so change the seed. Maybe this I need to raise the number a bit higher. I don't know. Let's give it a value of, as long as it disconnects, maybe a bit higher. Okay, maybe something like that. Okay, something like that. Okay, so now the problem with this is that we have many closed curve being formed, and because this closed curve have overlapping regions, like these are shared regions, so what we end up with is a lot of duplicated curves which we need to remove. Okay, so we need to do this kind of cleaning work. Okay, so I guess the first thing I want to do is to find the points where these converging regions are. Okay, to do that we can use, I guess, this discontinuity, plug this here, and you can see we can get all the points where there is a discontinuity in the curve, because remember this is a closed curve, so these are actually the discontinuity points which happen to coincide with the place that we want to split. Okay, So once we got this right, let's proceed on to do the splitting. Okay, as there are excessive point over here, what I'm going to do is I'm going to reduce this using cow duplicates. Leave one. Oops. Okay, this goes like this. Okay. I hope I'm getting it right. Okay. Okay, so now I have like broken this stuff up, but now what I need to do is to over at these areas we still have duplicate curves. Okay, what I've done is I splitted the closed curve into its individual pieces, but there are still duplicates because, for example, this region is shared by this and this, so we have actually two curves at each location, so we need to remove the duplicates. Okay, so I'm going to use a method that I found online recently, and I want to use it to remove the duplicates. Okay, so point on curves, set it to 0.5, and then we're going to use the cow duplicates again. This here. This item. Okay, this is going to be my item. This is going to be my point. Set to leave one. Okay, basically what this does is that we're going to create points here at the middle section, and then we're going to remove one of these, and in the process we are able to get the index of the points. Okay, and this index will correspond with that of the curve, so we can use that to find the curves to be removed. So connect to this. Okay, yeah, so let's do a list item to see whether we are getting some kind of result. Oh, you can see that we still have like, okay, they are broken up, but like there are a lot of this stuff together. That's because there's some kind of complex structure. So what I need to do is I need to put a flatten, I guess. Flatten tree, flatten the structure. Yeah, you can see now we have like one of these. So let me just pick a random number. Select this. Now you can see that, yeah, we have actually broken this thing up. Okay, so yeah, so I guess we have already removed the duplicated curves. Okay, so I'm going to remove this. Okay, so let's just see whether we have like created the curves correctly. Okay, so I'm going to go to surface, sub D, multi-pipe, right? See whether we can get our result. Okay, if we can get a result, that means we can proceed. Oh no, there's something wrong here. great. Okay, now it's working. Okay, because I have to put a flatten here. Can you see? Yeah, so now all these are connected. Okay, so all these are connected, and yeah, so we have created the framework over here. And okay, let me just show you how we can like give it a more like organic biological look to the overall form, which is what we want. Okay, so to do that, right, what you can do is can play with the node size and the strut size, essentially these two for a start. Okay, so we're gonna put this. Okay, gonna put a node size here. This will flatten everything. However, I want to slim down this, which I can control by changing the strut size, keep it smaller. Yeah, you can see now we have a more organic kind of look. Okay, so got a more organic kind of look to this whole structure, as if we got some cells like communicating with one another. Maybe something like that. Okay. Okay, now I still got one more thing to do, which is to create like a rim on the top here. Okay, and this part can be quite tricky. I hope that I can get it right the first time. Okay, so let me unhide this. Okay, so you can see that we got this initial surface. Now I need to get the rim here. Okay, so to do that, I can put in a deconstruct VREP. Connect the geometry here. Basically, I need to extract this edge here. Okay, let me just drag this over. Need to work with this. Okay, so what I'm going to do is I'm going to get this edge and going to use this to cut, or rather to split this curve up into many small pieces, so that we can later combine this onto the overall structure before we do the multi-pipe again. Okay, so I'm going to use the list item. Connect this to this. I got this. Okay, theoretically speaking, I should set the index here to 0. Okay, because this is actually index 0. So let me just show you what's happening. So what we have is actually the selection of index 0. So if I move this, you can see we are selecting other edges. Okay, so index 0 is what I want, so just leave it like that. And then we're going to, okay, this kind of tricky. I hope that I'm able to get it right. So I'm going to use these curves to split this curve. Okay, to do that I must go to intersect this one. Okay, splitting of curve using curves. Okay, so plug this here, plug this here. I got these points, and I'm going to use this point to shatter this. Okay, so shatter, this is my curve to be shattered. Okay, now I need to find the parameter. Okay, so the way to do it is as I have already done it before. Curve closest point. Okay, curve closest point. This is the point. This is the curve. I don't know whether I need to flatten this one, but let's see. And then the parameter, we connect this here. Okay, so we get, it ran like a lot of times. So let me see how many segments we got. 19 segments. Looks like correct. Okay, so I need to get this. Okay, let me try just type this item. That will give us an idea of whether we're getting this correct or not. Okay, so connect here. Doesn't seem correct. let's just plug this here, see what we got. Fortunately it's like I don't think we got the stuff. Okay, so I got these points. Let's see whether I need to flatten this. Okay, we got it. Okay, I need to do the flattening. Okay, yeah, so now I think I got it ready. Actually I don't need this. Okay, I don't need this anymore. Basically we need to flatten the point list. Okay, so now what I need to do is to merge this with the first set of curves. Okay, so make it a bit easier. Let's move this here so you can see. Okay, so I'm going to put a merge. Okay, I'm going to merge this and this, connect this to this. Okay, still not giving us some good result. Let me try to do a flatten here. Great. Let me hide all the rest. Okay, now we got the form and they're all like connected. Okay, they're all like connected. In theory, we can like fabricate this by printing. Okay, okay, I think you need to close this. Okay, so in theory, if you want this to be a full solid thing, you can close this by turning the cap. Now it's set to 0. We need to, I guess you can use the round. Okay, so I'm going to put a value of 1. Connect. See, yeah, you got this close up. Okay, so in theory, if I bake this, convert to NURBS, this should be a solid thing. Okay, we can do further modification because it's sub D to the form by removing certain sections, but due to time constraint, I'll just remove a few to let you see what further processes that we can do to this. Okay, so we're going to do a right mouse click, click the bake. Okay, let me just hide this. Okay, so I already baked this, and if you want to do further modification to the form, for example, you don't like this kind of look here, go to filter, subobject. Okay, let me zoom in. Okay, for example, let's say you want to have a more nicer blend over here, double click here, delete away this, and then you have a nicer blend. So you can still continue to do some fine adjustments to the form if that is what you desire. Okay, I'm not going to like spend too much time working through all of this, but I'll just show you a few demo. Okay, so you can see if I remove this, see, I can get like even better refinement. Okay, with that, I come to the end of this demo. Hope that's been useful. See you. Bye.